Lesson 3-4. Today, what we're going to be talking about is graphing, specifically the sine and cosine functions. Okay, so we're going to be graphing sine and cosine. We will be using our hand trick that we learned last class. We won't just be exclusively using our calculator to graph these. We have to have those values memorized, and so we're going to continue working on that. We will use the calculator some today, but what you're going to learn is with sine and cosine. Y'all, hey, catch on to this. Catch on. This is very important you catch this. This is a little, seems backwards at first to some students. Okay, sine is what function? Sine is equal to, what was it? Sine is y. And it's not just y by itself. It's y over r. Finally, cosine, x over, okay, when you go to graph, what's actually going to happen though, when we go to graph, this is true. This is a true statement. These are the ratios. You can substitute those out. When you go to graph, instead of saying y equals, I'm going to say f of x equals, okay? If you were graphing f of x equals sine, and then we'll usually use an x here, what's actually going to be the x value? What is in place of x? I'm sorry, what is x replaced? I'm saying that wrong. What is x replaced? Look over here. The theta. The theta is what is going to be your x variable. Okay? The x variable is actually going to be your theta. And it would be the same thing for sine. I'll do the letter G for sine. If you had g of x, it would be, did I say sine? I meant cosine. It's the same thing. Your theta is actually going to be what's on the x-axis. So what do I mean by that? You see this x value right there? This x value will not be the x-axis. This x value will actually be the dependent y value that comes out. So this side of the equation, over here, the function's height will actually be the y divided by r. Or in the case of cosine, the function's g of x, which would be like the height, will actually be the x over r. Does that make sense? So if you look at the equation, this part is what goes in there. The theta is what goes in these spots. The angle, that's theta. Okay, so that's how it'll work. All right. All right, so let's talk about the sine function. So the sine function, as you can read up there, it has to deal with, do you remember? Sine is y. So it's always measuring the vertical displacement. I don't see those words in here. So let's go ahead and put this in here. Sine is the, I want to add it in right here, the vertical displacement. The vertical displacement. Remember, displacement meant like distance, but it includes direction. So if a direction is negative, you would call it a negative distance, if you will. So sine is the vertical displacement. What sine will look like is this. It's going to be a wave that starts at the origin. It comes up, then it'll go down, and then it comes up. And right there, that would be one complete cycle, one complete wave right there. That, what I just drew, that is one complete cycle. That's what the sine curve will look like. Now, if you compare it to a unit circle, I'm going to do my best to draw a circle off to the side. If you compare it to a unit circle, so I'm drawing myself a circle. I'm going to put on an x-axis and a y-axis. If you're trying to figure out what am I doing, I'm going to compare what we did last class and the class before with the unit circle. Do you remember we start where on the unit circle? Where's the beginning point for a unit circle? We begin somewhere. Where do we begin? On the positive x-axis. This would be called 0. Okay, put a 0 over here. Actually, do I want to put that there? I want to put the 0 on the inside right there. That's where I put the 0. Now, do you remember by the time we get to the left side, what value goes over here? pi. And then if you went all the way around, what do you get when you go all the way around?
2 pi.
2 pi. Okay. So sine is the value of y. So I'm not going to fill in the x value, but I am going to ask you, what is the y value when you're on the x-axis? What is the y value? 0. And so 0 would go there. Technically, the x is 1. I'll go ahead and put a 1, but the y value is 0. That's why this point here is at 0, 0. Because the angle itself is 0, and the y value is 0. That's what you're graphing. Okay, when we move on up, let's say our point gets moved to where we are now. Let's see if it'll let me move just the point. It's not moving the point. I want to move that point. Let's say our point gets moved up here. What is the x value at that location? The x value is 0. Very good. What's the y value? It was the square root of 4 over 2, which reduces to become a 1. Okay, are you tracking with me? This is a circle with a radius 1. So at the very top of the circle, the coordinate is 0, 1. Do you remember how many pi's would this be? Let's see, it's in between 0 and 1 whole pi. What's in between 0 and 1 whole pi? Half of a pi. Pi divided by 2. So here's what that means. On this graph, this point right here, this point on the graph would have the coordinates. The x value would be the pi over 2. That's the pi over 2. The y value is the y value from the unit circle. What's our y value right there? 1. That's where the y value would be, if that makes sense. So what you're graphing is you're not graphing the x's from the unit circle. With sine, you are graphing the y values as the y's. The radians, the pi's, those are the x's. Okay, let's do just a couple more here. Let's go to this point right here. If I went over to this point, what is the x value? Remember, this circle has a radius of 1. What's the x value when you go left that radius? Negative 1. Okay, good. That's the x. What's the y value when you're on your x-axis? 0. So here's how that corresponds. That point would be right here. What you do is the x-coordinate is the angle. What's the angle at this spot? Pi. That's going to be the x-coordinate. The y-coordinate, since it's sine, is the y value on the unit circle. Which one's our y? 0. So that's where that point would be. It'll be pi comma 0. Are you kind of catching on to how this is formed? Okay, you tell me then. If this is 3 pi over 2, that's 3 pi over 2. That's hard to see. Let me do it again. 3 pi divided by 2. If that's where the radian is, and if the location of the point is 0 comma negative 1, what do you think is the coordinates that I need to label this point right there as? So you're using this spot. Perfect. That is my x, 3 pi over 2. Good job, Gio. And the y? Negative 1. This one. Oh, you said it before? Okay. Sorry. All right, we have one more point to label on there. If you went all the way around, I already have the red dot on there. I'll go ahead and leave it. I need to make this one red, though, to make it correspond. Okay, you get over to this point. If you go all the way around and back to this point, we would have the coordinates for this spot right there. What is the coordinate? What is the x-coordinate for this spot right here? 2 pi. If you go all the way around the circle, you've gone 2 pi radians. That's the x-coordinate. What's the y value? 0. You're back to this 0. That's how we come up with the sine curve. So what's the value from the unit circle that does not get placed on the curve at all? What is the thing we ignored the whole way around from over here? The x's. You do not touch the x's at all when you do the sine. That'll be for the cosine. Does that make sense? All right, that's sine. So that's how we'll build up our graph. So from here, we're going to break it down and use all the hand trick values. So it says make a table of values on x comma y on y equals sine x from the unit circle. So you could pull up a unit circle, which I have one. Let me pull it up. I have one right here. Might take it a second to open, but we can use the hand trick as well, which is what I would suggest. So using your left hand, Where is 0 on your left hand? Where would we say 0 is? Is it your thumb, index, middle? Well, let's start. Remind me, what's the thumb? Pi over 2. What's the index finger? Pi over 3. Middle finger? Pi over 4. Pi over 6. We skip 5. You won't ever be tested on that without a calculator. Finally, the pinky is anything without a denominator, which would be 0. So bend your pinky, flip your hand over. How many Y fingers do you have there? How many Y fingers do you have above the bend? None. So put square root of 0 over 2. We will reduce all of these at the end. Okay, now let's flip your hand back over. Let's go to pi over 6. Pi over 6 is which finger? The ring. So instead of the pinky, look, this represents the first quadrant. We've gone from the pinky, now we're on the ring. We're just going to move our way around. So bend your pinky, or not your pinky, I'm sorry, bend your ring finger, flip your hand over. How many Y's do you have? Square root 1 over 2. And you'll probably catch on to the pattern really quick. We go to the next spot, pi over 3. Oh, I skipped one. Pi over 3. Where's pi over 3? Which finger is pi over 3? It's the index. We skipped the middle on this chart. Okay, bend your index, flip your hand. How many Y's do you have there? Square root 3 over 2. Perfect. Okay, back over. Where is pi over 2? Thumb. Bend your thumb, flip your hand. How many Y's? Square root 4 over 2. Okay, now let's do 2 pi over 3. 2 pi over 3 uses the same finger as index. It's still pi over 3 finger. So to bend it, flip it. How many Y fingers do you have there? 3. So it's square root 3 over 2. I'm seeing some people just bend. Make sure you flip your hand. That's what evaluates the sine, the cosine, whatever. Okay, how about 5 pi over 6? Which finger is your pi over 6 finger? You're looking at your palm of your hand. You bend your ring. Now you flip it. That evaluates the sine. What do you get for sine of 5 pi over 6? Square root 1 over 2. Okay, now we get to pi. Which finger is pi? Pinky. It's no denominator. Bend your pinky. Flip your hand. How many Y's do you have? Okay, so you see the pattern? We were counting up. I skipped pi over 4. That's why we skipped a number there. And then I skipped 3 pi's over 4. That's why we skipped one there. But now we're to pi. Now we go to 7 pi over 6. We are now getting on the unit circle. 7 pi over 6 is where sine starts becoming negative because we're now going underneath the x-axis. If you think about the unit circle, the y's are going to start becoming negative now because if this is 0 and this is 1 whole pi and that's 2 pi, sine's going to start becoming negative because now we've passed pi. We are past pi, so now sine is negative because the y values are negative. And we are below the x-axis, so my y values are now negative. So 7 pi over 6, which finger do we use?
Your ring.
Ring. Bend your ring, flip your hand. How many y's there do you have? So we're going to make it negative square root 1 over 2. Good. Okay, how about 4 pi over 3? Which finger is index? Bend your index, flip your hand. 3, again, make it negative. Negative square root 3 over 2. Okay, how about 3 pi over 2? Bend your thumb, flip your hand.
-4.
Negative 4 over square root 2. Okay, great. How about 5 pi over 3? Again, y is still negative down here all the way till 2 pi because we're underneath. 5 pi over 3, which finger is that? Index. Bend your index, flip your hand. How many y's do you have there? So it's negative square root 3 over 2. Finally, I got 2 left, sorry. 11 pi over 6, which finger is that? Ring. Bend your ring, flip your hand. How many y's do you have there?
Interruption again, teachers, students.
Okay, and for those who are watching the video here, here is the unit circle I was talking about. If you weren't following the hand trick, just pause your video, take a picture of that. That's where we got the values. We went around taking the y values, going around this circle. Okay, now picking back up. 2 pi, which finger is that? Pinky. Bend your pinky, flip your hand over. How many y's do you have there? 0. So 0 is not necessarily negative. It's not positive. It's just 0. So I'm just going to do square root of 0 over 2. Now, some of these can reduce, some of them cannot. The numbers that cannot would be any square roots of 2 don't ever reduce, and square roots of 3 don't reduce. Everything else will reduce. So this will reduce. What is the square root of 0 divided by 2? 0. Okay, how about square root 1 over 2?
1/2.
1/2. You know what might be quicker? Let's do anyone that has a 0 as 0. Let's go ahead and just do that all the way across. That has a 0. This also has a 0. Let's go ahead and do those all the way across. Now, anything that has a square root of 1 over 2 becomes 1/2. So this 5 pi over 6 is also going to be 1/2. 7 pi over 6 will be negative 1/2. And 11 pi over 6 will be negative 1/2. Square root of 3 over 2 will not reduce. That will not change. The square root of 3 over 2 will not change. That one, it's hard to tell that it's a negative. Let me go ahead and, there we go. And this one does not change either. Okay, but the square root of 4 will. What is the square root of 4? 2. And 2 divided by 2 is 1. So that'll become a 1. Anywhere you have a square root of 4, well, this one will become a negative 1. There we go. Okay, so when we go on to part B, let's make sure we're understanding how this works. What's the interval where sine is increasing? Where sine is increasing. And this might help if you think about the unit circle, because you start here. For how long is sine increasing? Well, sine is which variable? Sine is y. So for how long is y increasing? Does it always increase? There we go. From really down to here up to there is when sine is increasing, and then sine is decreasing from here to there. But we start at 0, so I'm going to say on this interval we are increasing. So we are increasing. We start at 0. With intervals, you always just use parentheses. If it was domain, you could use brackets. But if they say intervals, intervals is like domain, but you never use brackets, you just use parentheses. We increase from 0 to this spot there. What is that spot? Pi over 2. So we increase from 0 to pi over 2. And we also increase, as Giovanni said, so I want to do a union, from here going back up. So from 0 to, if you go all the way around, you've reached 2 pi. So from, not 0, that's not 0. What spot is that? Goodness. Let's try that again. Where is this spot? If this is 0, that's 1 pi over 2. 1 whole pi is like 2 pi over 2. So it goes 1 pi over 2, 2 pi over 2.
It's 3 pi over
3 pi over 2. Very good. It's 3/2 of pi. Okay, and then finally, what is this value right there? 2 pi. That's where we increase. Now, where does this graph decrease? So you could be looking at this table, but I'm going to use the unit circle. Where are y's decreasing from? Just visually. Top, the bottom, the left, the right. From the top, going around this way to the bottom. That's where we're decreasing. We are decreasing. What value do we start decreasing from? What is that up there? Give it to me in radians, meaning the red values. What value would be right there?
pi over 2.
Pi over 2. Very good. We start decreasing at pi over 2, which on their chart is right here. We start decreasing from there all the way until what value? 3 pi over 2. That's when we stop decreasing. 3 pi over 2. So as a reminder, when they say intervals, intervals means x values. That's what that means. When you see intervals, that means what are the x values. You don't include the y's, you just say the x values, which when you're graphing would be the angles, the thetas. Okay? The x values become the radians. That's what they are. The x value are the radians. That's the red. Okay, last thing, state the maximum and the minimum point. So using the unit circle for sine, sine is y. Where is the maximum? At the very top. Now you list it as an x and a y. The x is the radians. How many radians is the very, very top?
Pi over 2.
Pi over 2, perfect. This is it right there. It's pi over 2 with the y value of 1. That's the maximum. So I don't know what color I haven't used here. I'm going to go ahead and just do this in red. This value right here represents the maximum. That's the greatest the graph ever is. Right there. That is its maximum value. It looks like May. Max. The maximum would be pi over 2, comma 1. And that is an absolute maximum. Sine does not get any higher. So I'll go ahead and throw in the word absolute on there. Okay, what is the minimum value on the unit circle? Where is the minimum value?
Three pi over two.
Ah, at the very bottom, right? So it'd be 3 pi over 2. Very good. The absolute minimum, remember, absolute means nothing ever goes lower, is at 3 pi over 2, which on the chart is this value right there. This is the minimum value. What's the y value at its minimum? -1. Okay, so there's a lot of the sine function right there. All right. Oh, the decrease is one constant piece. So what's different on this is you start at 0, so it breaks up the increasing. You start increasing, but then you have this big gap of decreasing, and then you start increasing again. Let me show you on the previous slide. You remember when I did this graph over here? Notice if the graph starts here, what's it doing at the start? Increasing. But once you reach the top, there's this break, and you decrease that whole half of the whole half. That's terrible English. You decrease for half of the graph there, but then you finally increase again. Does that make sense on how it is? So the interval on sine, it increases for a quarter of the graph, then it decreases for half, and then it increases for another quarter. So it does increase for half the graph. It does decrease for half the graph. It's just the increasing are broken up between the half that's decreasing. Does that make sense? Am I throwing you off saying all that? Okay. So now it says here to sketch the graph, it's going to walk you through basically what I just told you to do. You'd plot those points, but it would walk you through. The domain. The domain, if sine is never ending, we'll go ahead and put arrows on this. Let's do this. If sine is never ending, domain means x values. Your x values are all reals, okay? This wave never stops. It just continues being a wave. It keeps going and going and going, okay? So the domain, remember, domain means what values? X. And truthfully, this is referring to the radians. The amounts of pi's, you just keep going around and around that circle. It's all reals. Let's talk about the range. Is the range, what values the range deal with? The y's. Do the y's go down forever and up forever? Nope, they don't. What are they limited in between? We always go low to high. What's the lowest value you'll ever have? What's this value right there? That's the lowest. That's 3 pi over 2, comma, -1. The range deals with the y value, so -1's the lowest. Now, when domain and range, you use brackets. If it's a value attained, that's the minimum. Okay, what's the maximum value? Pi over 2, comma, 1. Again, we are listing the y's, though, for a range. X domain is x's. We're talking about the range, so we're doing the y's, so I put the value 1 in there. Sine and cosine will have the same range. It's between -1 and 1. Okay, amplitude. Amplitude, if you remember, it's the top of the wave to the bottom of the wave divided by 2. The amplitude, if you remember, was the top of the wave to the bottom of the wave divided by 2. Well, how we wrote this out on the lesson 3.1 is I said that is 2 amplitudes right there. Top to bottom is 2 amplitudes. I don't know if you remember that. So the math was the maximum minus the minimum divided by 2. Now, what is the height of the maximum? 1 minus, what's the height of the minimum? -1 divided by 2. What happens if you have a minus a negative? They add. 1 plus 1 is 2, so it becomes 2 over 2, and 2 over 2 can simplify to become 1. The amplitude is 1. That means from the middle of the graph, the midline, up, it's 1 unit, as we could see it easily. Okay, a period is 1 full cycle. We've already talked about this today. Sine has a cycle from here to here. That's truthfully where it goes, or you go max to max or min to min, but since I don't have that, this would be 1 period. How long is the period here? That's 1 period or 1 cycle. 1 period is 1 cycle. How long is that? 2 pi. A period is 2 pi. The key points are zeros and maximums, zeros and extrema is what I meant to say. The key points are zeros and extrema. So let's label those out in order, starting with this first one. What's the coordinates of this 0? Actually, let me put that in here. These are zeros and extrema. If you're wondering what are key points, zeros and extrema are considered key points. So the first one here is 0, 0. Actually, let's just write it out like that. We have zeros at 0, 0. Okay, what's the next 0 coordinate right here? It's kind of hard to see because I wrote it over.
0, pi.
Oh, he says 0, pi. Does that mean up pi? Pi, comma 0. Okay, so we're going to have pi, comma 0. This looks weird with all the commas. I'll separate them with semicolons. And we have one more 0. Where is that 0?
2 pi,
2 pi, comma 0. Good. There's our 3 zeros. We had that maximum already. We already wrote that, but we'll do it again just for the practice of it. What's the x value there? Pi over 2. And the y value? 1. And then finally the minimum is right here. 3 pi over 2 and -1. That's your sine function. That's what it looked like as a graph. So frequently we use a unit circle because you can see the pattern of values and you get your x's and y's at the same time. But if you just wanted to graph the sine function, it would look like this wave. Okay, the unit circle is just to help you memorize all the values, if you will. But that's what the graph actually looks like. All right, so the key points that we had, let's go back over here. The key points occurred at 0, pi over 2, pi, 3 pi over 2, 2 pi, which means this. The key points always occur at your pinky or your thumb on the hand trick. Where do the key points occur again? Pinky or your thumb. Okay, so I have it listed up here. 0 would be which one, pinky or thumb? Pinky, pi over 2, thumb. Pi, pinky, 3 pi over 2, thumb. 2 pi, pinky. Okay, good. I'll do a unit circle on the side to help us fill out this chart. We're not going to spend much time here. Hopefully, we can do this pretty quickly. So we always write out 0 here, 2 pi there, 1 pi goes there. I'll go ahead and put which value would go right up top. This is pi over 2. Okay, what would go down at the bottom? 3 pi over 2 would go there. Okay, I'm going to go ahead and put that. Those are going to be where the key points come from. So let's start with sine. Looking at 0, which finger did you say to bend? You already told me once. Pinky. Bend your pinky, flip your hand. How many sine fingers do you have?
0.
Okay, go ahead, put 0, square root 0 over 2. How many cosine fingers would you have? 4. And that would make tangent be, remember it's y, square root of y fingers divided by square root of x fingers. So it'd be square root 0 divided by square root 4. Okay, go to the next one. We'll reduce all these at the end. Let's go to pi over 2. So that would be the values here. At pi over 2, which finger are you now bending? Thumb. Bend your thumb, flip your hand. What are you getting for your y's?
4.
Square root 4 over 2. Okay, what are you getting for x's? Square root 0 over 2, I hear. Okay, and what about tangent then? Sine is y, cos is x, tangent is y over x. How many y's? How many x's? Square root 4 over square root 0. Okay, next, pi. Flip your hand back over. Which one's pi again? Pinky. So when we flip this over, it should be just like the 0. There will be one difference.
Negative.
It is a negative. Very good. So over here, when we start off at 0, which value was positive? The x. Now, which value is negative? Nope, not y when you're on the left. The x. The x is negative. So this needs to be a negative this time. And so what does that mean tangent is? It's the square root of 0 divided by negative square root 4. The reason x is negative is because we're on the left. This is the x-axis, this is the y-axis. Okay, going to 3 pi over 2. Now which value is going to be negative? The x, the y? Both. At 3 pi over 2, what's going to be negative? Nope. Here we go. Flip your thumb, fin your hand. You'll notice cosine will not be negative because it's 0. Cosine will be 0, but y will be negative. So if you're lost, why are they both not negative? Because we're at 0 on the x. 0 is not positive, nor is it negative. So this time we'd have a negative square root 4 divided by the square root of 0 for tangent. Finally, last one, 2 pi. Which finger do we bend? Pinky. Which value is going to be positive? 0 can't be positive or negative, so which one's positive, x or y? And you're here.
What? You said which one's positive?
Positive. X is positive because we're to the right. So the x will be a positive value. There's nothing negative. So here we already had that this is square root 0. This is square root 4. And this would be square root 0 over square root 4. Okay, when you go through these, every single one of these could reduce. Every single one. Because the only numbers you don't reduce are when it's the square root of 2 or a square root of 3. Amir, make sure you're staying with me now. So anything that's not a square root of 2 or a square root of 3 gets reduced, which means everything gets reduced. What's the square root of 0? 0. And 0 divided by 2 is 0. Let's go ahead and every time we see a 0 in the numerator, put the value as 0. If you see a 0 in the numerator, put it as a 0. A 0 in the numerator will reduce to become 0. Go ahead and do that all the way across. So you should have zeros like I do. Okay. Once we do that, what is the square root of 4? 2. And 2 divided by 2 is 1. Now be careful on this because some of them are going to be negative. So that's a positive 1, positive 1. When this is square root of 4 over 2. Square root of 4 over 2. This one, though, is negative square root of 4 over 2. So this is negative 1. This is negative 1. Then here we're back to positive 1. So this is just sine and cosine. Positive 1, negative 1, negative 1, positive 1. Tangent has something weird, though. Look at the tangents. We have a square root of 4 is 2. The square root of 0 is 0. What is 2 divided by 0?
2. 1, right?
No, not when you divide by 0. Are you allowed to divide by 0? No, what does that make it? Undefined. Truthfully, you should not say equals undefined. Undefined is not equal to anything, so you scratch it out like that, and you say, I'm just going to say U and D. Same thing here, U and D. Tangent is undefined. That'll be a vertical asymptote when it comes to graphing tangent. Those would be the key points for those 3 functions. The 5 key points for those 3 functions, there they are. The zeros are obviously zeros. The ones and negative ones, those are maximums and minimums. The positive ones being maxes, the negative ones being minimums. That would be the key points for those functions. All right. Let's go to example 2. Now, let's talk about what would happen here. It says use the 5 key points of the parent function to graph y equals 2 sine x. I have a question for you. This 2 right there, would you say that's on the inside with x or is it on the outside? Outside. So which value is it going to multiply with? The x's or the y's if it's on the outside?
The Y.
The y's. And are y's liars or truth tellers?
True.
Truth tellers. So stay with me here. It's truth tellers. So all the y values are going to get multiplied by 2. Notice your x's do not change. So we already found these values earlier. Do you remember how the sine wave started here and it went like this? That was ugly, but do you remember how it went like that? So we started at 0. What is 0 times 2?
0.
Okay, so it's still going to be 0. I could show the math if you wanted me to. It would be 2 times 0, but the value is going to be 0. Now, pi over 2 was its maximum. Do you remember what the maximum was for sine? Look back if you need to. You just look at your previous slide right up here. The first key point was a 0. What was the second key point? A 1. So this will be 2 times 1. What's 2 times 1? 2. Good. So the next, at pi over 2, we should have a value of 2. There we go. Okay, what about pi? Well, what was our key point at pi? It was 0. So what's 2 times 0? 0. We're back at 0. We're back to pi, at pi, we're back to 0. Okay, 3 pi over 2. Now in the unit circle, that's at the very bottom. When y is at its minimum value of -1. What's 2 times -1? -2. So at 3 pi over 2, we're going to be down at -2. And then finally at 2 pi. You can look back if you need to. At 2 pi, what's the y value, the sine value? 0. So it's 2 times 0. What's 2 times 0? 0. We're back to 0. Okay, connect your dots with the wave, and you will have your graph. That. So we changed what's called the amplitude. The amplitude was 1 unit. Now, from top to bottom, how many units across is it from 2 to -2? How many units is that? 4. It's 4 from top to bottom, but then you divide that by 2 because that's 2 amplitudes. What's 4 divided by 2? 2. This value right here, your A value is what they call that. That is the amplitude. Your value in front of sine or cosine, the multiplier, that is the amplitude. That tells you from the midline to the top of the graph how tall it'll be, or from the midline to the bottom. Since this is a positive 2, that means from the midline to the maximum is going to be 2 units. From the midline to the bottom will be 2 units. That's what that 2 does. Okay, that's your amplitude. We'll give it the letter A in the coming days. Actually, we'll give it to it today. This is a graphing assignment. All right, how about this one? It says complete the table for the 5 key points of the parent function in the graph, -3 times sine of 2x. Now put a parenthesis around this 2x, would you? Make sure no one's confused on that. Now we have 2 transformations this time. Let's start with the -3. What's the -3 doing? It is multiplying, but is it multiplying with the y values or multiplying with the x values? Meaning, is it on the inside or is it on the outside? On the outside. So what if it's on the outside, does it multiply with the x's or the y's? Y's. Is it truth teller or liar? Truth teller. So for the rule here, what I'm going to do is on the y's, I'm going to put -3y. Which means I'm going to multiply this y value by -3. Make sense? Okay, tell me what's happening with the 2x. It is multiplying, but is that 2 multiplying x's or y's? X. Is x a liar or truth teller? Liar. So am I actually going to multiply by 2? What are we going to do instead? We're going to divide by 2. So for your rule, take your x and divide it by 2, like that. That's what we're going to put for our rule. So x's get divided by 2, y's get multiplied by 3. So here's my point. My first point was 0, 0. What's going to happen is 0 is going to get divided by 2, and this 0 is going to get multiplied by 3. -3, I'm sorry. So what is 0 divided by 2? 0. What's negative 3 times 0? Oop, try again. Negative 3 times 0 is 0. So our first point is 0, 0. Is that what you said? Oh, I thought you said 3. I'm sorry. Okay, that's my fault. Let's try the next one. We're going to take pi over 2, and pi over 2, I'm going to write pi over 2 this way, is going to get divided by 2. And then we're going to take negative 3 and multiply it times the 1. Okay, when pi gets divided by 2, then gets divided by 2 more. That's like getting divided by how much? Pi divided by 2 divided by 2 is like pi getting divided by how much? It's going to be pi over 4. Pi divided by 4. Negative 3 times 1 is negative 3. So here it is. Here's pi over 2. If you cut that in half, that must be pi over 4 right here. At pi over 4, we're down at negative 3. Put the point right down there. Let's go on to the next one. We're taking the point, the key point, pi comma 0, but we're going to take pi, and according to the rule, we'll divide pi by 2, and the 0 is going to get multiplied by negative 3. There's nothing to reduce with pi over 2. It just stays pi over 2. What's negative 3 times 0? So we're going to go to pi over 2 comma 0. So here's pi over 2, 0, right there, plot it. We got that point. Next one. I have 3 pi over 2. By rule, 3 pi over 2 is going to get divided by 2. So I'm going to write this fraction sideways. So it's 3 pi over 2 getting divided by 2. I also have this negative 1 that's going to get multiplied by negative 3. It'll be negative 3 times negative 1. When we go to simplify, I have 3 pi over 2 being divided by 2. That means 3 pi over 2 gets divided by 2, then divided by 2 again. 3 pi over 2 is getting divided by how much? If it gets divided by 2 and then gets divided by 2 again, how much do you get divided by? 4. Very good. And what's negative 3 times a negative 1? Positive 3. So 3 pi over 4 is right here. This is 3 pi over 4. We need to be at positive 3. Put that point there. We've made our way all the way around. Last one. We take our 2 pi. And 2 pi by rule needs to get divided by 2. And then for the y, we multiply it by negative 3. So it'll be negative 3 times 0. What is 2 pi divided by 2?
Pi.
Just pi. And then what's negative 3 times 0?
Negative.
No, 0. And so at 1 whole pi, there it is. So there's our graph. Let's connect our dots. The wave. By the way, you would say the amplitude is 3. Even though it goes down, you always list your amplitude as a positive value. So it's from the midline to the top, it's 3 units. So we always say the amplitude is a positive value. Never say a negative. The amplitude here is 3 for the record. Now, let's talk about the transformations that have occurred. What are the differences on this graph as opposed to the previous graphs we've seen? What was the original maximum of sine? Do y'all remember what the original maximum was? I know the last problem was 2, but the very first time when we did the parent function?
Maximum.
Maximum was 1. What was the original minimum? Negative 1. So this one has been vertically stretched. It no longer just goes to 1 and negative 1. How high does this one go? 3, and then a depth of negative 3. So he's vertically stretched by a factor of 3. So here it says describe the transformations. You would say the graph has been vertically dilated is actually the word. Actually, I'm not sure if that's how you spell vertically. So how about vertical dilation? I know that's correct. Vertical dilation by factor 3. Something else I know that is true is sine doesn't usually decrease first. What does sine normally do? It usually increases first. This one decreases first. We have reflected it across which axis? If normally it goes this way, now we're going this way. We've reflected across the x-axis. So we have a vertical reflection across the x-axis, a vertical reflection. This is the negative. Across the x-axis. Finally, there was something else that changed. It was the horizontal piece. What did we do to the horizontals? The x's. We divided by 2. I don't know what's going on, my deal. It's shaking. I don't know what's going on. Okay, so horizontally, if you divide by 2, is that a translation, a dilation, or reflection? Which one means you're either multiplying or dividing? Translation means adding or subtracting. Dilation. This is a horizontal dilation. Reflection means negative. Dilation means multiply or divide. And you'd say by factor, since we're dividing by 2, you'd say by factor 1/2. Horizontal dilation by factor 1/2. Those were our 3 transformations there. Okay, we have done a lot of nitty and gritty graphing. We could practice more. Do y'all want to keep practicing more?
Can you go back real quick?
Yep, I can go back. Are you wanting to read that down there?
Okay.
Go ahead. Okay, I don't want to take too much time, but how about this? Just walk me through the rule here. What does this 2 do? Does it change the x's or the y's? I just want to make sure everybody understands. Is this changing x's or y's? This would change y's. Why? How come? Not rather than me saying why, because you can't tell what I'm talking about. How come?
Outside?
Outside. Good. What about this +2?
For the what?
It actually changes the y's as well because it's not inside the parentheses. It would change the y. So how do I change the x's on this problem? Trick question. When I say how do you change the x's, that's a trick question because the correct answer is you don't change the x's. So the rule in this one would be, if you want to do it, is the x's stay the same, but what do you do to the y's? You multiply by 2, and you also add. So it would be 2y times 2. So all these values, you would just go down your chart. Each x would stay the same. Every x value would stay the same, but what would change is each y value would first be multiplied by 2, and then you would add 2 units. Does that make sense? If you want to try that on your own. I'll leave that there for you. If you want to try it later, you can always come back and compare it. Okay? Let's go try number 2 and then number 6 on the back of the packet. Now that we've done all that, we're going to start on cosine. As it says up there, you probably have a great idea of how cosine works because we've done some of it already on different charts. Here's how cosine looks different. Remember where sine began from when we started its wave? Where was the very first point for sine? 0, 0. Well, what's different on cosine is cosine starts at its maximum, but it follows the exact same wave because they had the same exact value. So that would be one complete cycle. I drew that horrible, but this would be one complete cycle. So what's unique about cosine is it does not start at the origin. Where does cosine start? At its maximum. This value here is 0. This next maximum over here is 2 pi. What value is in between 0 and 2 pi? Pi. That means pi is located, the minimum is at pi, whereas these two zeros would be pi over 2 and 3 pi over 2. If you want to put that in, this is pi over 2, that 0. This 0 occurs at 3 pi over 2. That makes sense? Once again, what's the maximum height? What was the maximum height for sine? What was the greatest a unit circle? It square root of 4 over 2. What did that reduce to become? 1. The greatest value is 1. What's the minimum value? -1. Yep. That's how it's going to be placed. Okay? So I'm not going to talk about this as much because we've already done so much on sine. So when we go to the next slide, this is that long table. We're going to go a little bit quicker this time because I don't want to run us out of time filling this table out. So cosine, I want you to think in terms of the unit circle. Cosine is going to start, where do we say? Look at the unit circle. Cosine is what variable again? Sine is y, cos is x. When you do this, cosine starts at its maximum because it's furthest to the right. One more time, I'll say that again. Cosine begins at its maximum because why? We're furthest to the right. So on a unit circle, you're just taking the x's. You start at 1. So I'm going to go quicker this time. Add a hall pass. Yeah. Okay. Now we're going to count down. So 1 is the same thing as square root 4/2. So what that value is right here, this is going to be square root 3/2. We start decreasing. Sorry, I didn't say that. Why does cosine decrease as you move along this unit circle? Why does it start decreasing? Because which way is that point moving? Left. So it decreases. This is square root 3/2. I have a skipped value in there. So this becomes 1/2. This becomes the square root of 1/2, which is just 1/2. At pi/2, what is the cosine at pi/2? Here's pi/2 right there. What's the x value on that spot? 0. That's correct. The x value is 0 because it's on the y-axis. So this one's going to be a 0. 2 pi/3. Now we're on the left side. What happens on the left side? Negative. We're going to have a negative 1/2. When you reduce that, that would be a negative square root of 1/2. The next one will be negative square root 3/2. At pi, I want to place the point. What's the x value at pi?
-1.
Very good. -1. So this becomes a -1. And now we start working our way back around. So this will be negative 1/2. This is negative square root 3/2. And then we come to this point here at 3 pi/2. At 3 pi/2. What's the x value? Not the y. What's the x value at 3 pi/2? 0. You got it. 0. And so this value is 0 there. And now we start working our way positives. This is 1/2. This is square root 3/2. And finally, 2 pi, we get back to the maximum value of 1. So that's what the values would look like. I went a lot faster. Now, when you talk about increasing and decreasing, what's a little bit tricky is we're not looking at the y values anymore. We need to look at the x. What's happening to cosine on this first interval? What is cosine doing? Increasing or decreasing? Remember, think of x's. What are my x's doing? I first decrease. Even though it goes up, that doesn't matter because cosine doesn't go up and down. Which way does cosine move?
That's right.
Left and right. What is my point first doing? Moving left or moving right? Left. So cosine first decreases all the way from 0 to pi. Cosine decreases from 0 to pi. Now, once you hit pi and you work your way around the circle this way, what happens to cosine now? Since I'm moving to the right, it increases. It increases from pi to 2 pi. Now look up in the table. How many maximums and minimums do you see? Remember what the maximum is supposed to be. It's supposed to be a 1. How many maximums do you see? 2. And how many minimums do you see? There's my maximums. This is my minimum. So max, min, max. They are absolute maximums. We have at 0, 1 and 2 pi comma 1. The absolute minimum, this is when the x value is 1. X value is 1 at pi. Did I say 1? I meant negative 1. I said 1. How many zeros are on there? 2. Those are the 5 key points. So when we talk about the five key points, we're talking about maximums, minimums, and zeros. There should be 5 of them. That's what those are. Those are the zeros. Okay? Next slide here. Let's continue with the graph of cosine. It says, tell me about my domain. Remember, domain means x values. What does it look like the x values are doing here? Did they stop or they keep going forever? They keep going forever. So put XER. These continue on forever. They're all reals. The range. Does my graph go down forever? Does it go up forever? No. What's the lowest this graph travels?
-1.
-1. You put a bracket because you hit that point and it's a solid line, so solid bracket. What's the highest this graph travels? What would that make the amplitude? Now, again, an amplitude, truthfully, is from the midline up. Or you could think from top to bottom divided by 2. That right there, what I just drew, is 1 amplitude. How many units is that? 1. The amplitude is 1. For cosine, just like sine, their amplitude is 1. What's a period? Period is the length to go from maximum to maximum or to complete one full wave. That right there is 1 period. How many x units is it to do a full period? That's right, it's 2 pi. Finally, our key points. How many key points are there? 5. I'll do zeros first. We had a 0 at, how would you list this coordinate here? Yep. You would say pi over 2, comma, 0, and the other? 3 pi over 2, comma, 0. Hit the blue button, get you started. Okay, how about the maximums? How many maximums did this graph have? 2. What's the x coordinate here? See, the y is 1. What's the x? 0. So we'll have 0, 1. And what's the x coordinate here? 2 pi. Okay, start typing your ID. All right, last one. How about, what color have I not used here? Blue. The minimum. What's the coordinate for that minimum? Pi is the x value. What's the y value? -1. All right, great. Here's what's kind of tricky on cosine. The y values when you graph are the x values on the unit circle. I'm going to say that again. Cos is x. So when you use your unit circle, you're using the x values. But when you graph it, those x values magically become the y's because the theta, the radians, are your x-axis. Okay? So the y value itself is the x divided by r. That throws off some students. So here we go. Let's take a look at example 4. It says complete the table for the 5 key points of this. Y equals 1.5 cosine. All right, tell me, what's that 1.5 doing? Is it multiplying the inside or the outside? The outside. That means I'm multiplying the y values. Is y a liar or a truth teller? True teller. So my rule here, x stays the same, but y gets multiplied by 1.5. So you can say 1.5 times y. That's what my rule would be. So my first point would be 0, and then 1.5 times 1. What is 1.5 times 1? 1.5. So this cosine graph would start here. That would be its initial point, and that will be its maximum. The next point, which is pi over 2, comma 0. Pi over 2 remains, but I have 1.5 times 0. What is 1.5 times 0? 0, good. So we'll have the next point at pi over 2, comma, 0. Pi over 2, 0. Third point, at pi, I then take my 1.5 and I multiply it times the y value of -1. -1.5, perfect. That will be its minimum. 3 pi over 2. And then 1.5 times 0. Because that's the rule. 1.5 times the y. So we have 3 pi over 2. What's 1.5 times 0? 0. So 3 pi over 2, we have a 0 here. Finally, last point. 2 pi, and then 1.5 times 1. 1.5. Oops, 2 pi. There we go. Connect your dots, and we'll have it. All right. What type of transformation occurred this time? What on the rule? What did we do on the rule? Look at my rule. What did I do to the function here? Multiplied y's. Is y vertical or horizontal? Vertical. And when you multiply, is that a translation, dilation, or a reflection? Dilation. So what we would write in here is we had a vertical dilation by factor 1.5. That's the transformation that occurred. On the next slide, I have a part B. Let me see here. And an extra practice. Okay, last time here for this, and then we'll complete and let you go to your questions at the back. It says complete the table for the 5 key points given this. Okay, walk me through here. I see this -2. What's the -2 actually multiplying? The x value or the y value? The y. Very good. What about this 1/2? What's it multiplying? The x. Tell me about when you multiply the y. Is that multiplying a liar or a truth teller? Truth. So I actually will multiply y's by -2. When I multiply the x's by 1/2, is that a liar or truth teller? Liar. So what you do, fraction means multiply by 1, divide by 2. Instead, I will multiply by 2, divide by 1. What is multiplying by 2, dividing by 1 the same thing as? Well, I'll show you. What happens is you have 2 over 1 times x, and then -2 times your y. That's the rule here. What is 2 over 1, though? The same thing as 2. If we're going to multiply x's by 2, y's get multiplied by -2. So let's go through and fill our points. So our x gets multiplied by 2. You don't have to do 2 over 1. 2 over 1, simply put, is 2. So x gets multiplied by 2. Y gets multiplied by -2. What is 2 times 0? What is -2 times 1? -2. So we plot that point. Next, I take 2 and I multiply that times pi over 2. And then I take -2 and I multiply that times 0. What is 2 times pi over 2? Those cancel out and you're left with pi and 0. At pi, we have 0. Next point, I take 2 and that's going to multiply times pi. And I take -2 and that's going to multiply times -1. What's 2 times pi? 2 pi. And then -2 times -1 is +2. At 2 pi, we were at positive 2. Here, I take 2, and it multiplies times 3 pi over 2. And then I take negative 2, and it multiplies times 0. What is 2 times 3 pi over 2? Just 3 pi. The 2 that's multiplying, the 2 that's dividing cancel each other out. And what's negative 2 times 0? 0. So at 3 pi, we're at 0. Finally, last point. I'm going to take 2 and multiply that times 2 pi. And then I'll take negative 2 and multiply that times 1. 2 times 2 pi is 4 pi. And negative 2 times 1? Negative 2. So at 4 pi, we are at negative 2. That right there will become our wave. This has 3 transformations, believe it or not. It has 3 transformations. The first transformation, we multiplied on the outside the y by negative 2. If you multiply y, it's a vertical or horizontal? Vertical. So going in order this time, the negative is the negative on the negative 2. Is that negative a dilation, translation, or reflection? What do y'all think? Translation, dilation, reflection? It's a reflection. So we first have a vertical reflection across the x-axis. Okay, I already filled this in. What happened here is since x's are getting multiplied by 2, that's a horizontal dilation by factor 2. Y was getting multiplied by negative 2, so the negative is a vertical reflection. And since it's vertical, you cross your x-axis. And since y is also getting multiplied by 2, it was also a vertical dilation by 2. That's there. You have one more you can try on your own here. I'm going to leave that. I will post it online so you can go through Google Classroom to look for those. But I'm going to leave that for you, extra practice. What you now need to do is number 1 and then number 3. And once you complete those, we will come back and look at number 4, number 5. Number 4 and number 5 do a better job of summarizing the whole lesson. We'll look at those.
Yeah, how do you?
I'll help you. Don't forget, once you have them all completed, to submit them online. So you can scan that QR code, or you can just Google My AP Classroom. Here's your instructions, the name, the function you're doing there. But after you log in, select My AP Classroom, select AP Pre-Calculus. You'll look for, it's a yellow box up the top, sine and cosine function graphs quiz. You'll see it, and it will usually ask you some check boxes, whatever. Fill those out, and then submit your online. All right, that's a wrap. Don't forget about Delta Math.